Okay, hello Cloud Gurus and welcome to this lecture. In this lecture, we're going to take a look at the GCP services aimed at development and APIs. We'll start our journey with a look at Cloud Source Repositories. Cloud Source Repositories offers hosted, private Git repositories with integrations to GCP and other hosted repositories. Now, if you're comparing this to the AWS world, this would match up with AWS's Code Commit service, but a comparison to a much better known service would be GitHub. Now, Cloud Source Repositories supports the standard Git functionality, but it doesn't have the enhanced workflow support like pull requests that GitHub has. That said, you can set it up so that it'll automatically sync from GitHub or Bitbucket. That can let you use one of those other tools for your primary development base and still use Cloud Source Repositories on the GCP side. Now, a reason why you might want to use this is because it has such a natural integration with Stackdriver Debugger. We take a closer look at Stackdriver Debugger in another lecture, but it can let you live debug deployed apps. The way you pay for Cloud Source Repositories is that every time a particular user is active on a particular project in a month, that's charged. And you also pay for the storage space that you use over time. Of course, we can never forget the data egress charges, and those come into play here too. But once you've got your source code hosted somewhere and you start making changes to it, you want something to happen with that, and that's where Container Builder comes in. Container Builder turns your source code into build artifacts packaged as a Docker image, but really, you don't actually have to produce any Docker images. In a blog post, Google even says there's no requirement that your build produce a container as output. The AWS service that most closely resembles this would be Amazon Code Build, but again, you're probably more familiar with something like Travis CI. And if you didn't want a hosted service, then you could always use something like Jenkins. Now, Container Builder can be connected up to your Cloud Source repository so that it builds any branch, tag, or commit, but you could also zip up your source code and dump it in a GCS bucket to kick things off. Now, as I alluded to before, you can trigger this from GitHub and Bitbucket if you use the Cloud Source Repository's RepoSync feature. Now, it's interesting to note that even though they only promise you one build at a time, Container Builder can and will run several builds in parallel if they have the capacity. That can be particularly good when you have multiple developers working on the same project. Now, if you already have a Docker file, this is super simple to set up. In fact, some people have even built and pushed Docker images without Docker installed on their machine. But you're not limited to what a Docker file can do either. If you describe your build steps in their JSON or YAML file format, it's even more flexible and you can parallelize steps. Now, you can definitely have Container Builder push the built images to the Google Container Registry, but really, you could export artifacts during your build steps to Google Cloud Storage or anywhere else you find useful. Container Builder will hold on to your build logs and keep your build history around so that you can take a look at it later. Now, with Container Builder, you pay per minute of build time, but you don't pay anything at all until you've gone over 120 minutes in a particular day. Now, I already mentioned it when talking about Container Builder, but next up we have Container Registry. Google Container Registry is fast, private, Docker image storage that's based on Google Cloud Storage and has Docker v2 registry API support. When Container Builder builds an image, this is the likely place to put it. Now, you might compare this to Amazon's ECR, their Elastic Container Registry service, but Docker Hub is probably much better known. Now, Container Registry is really some interesting magic. What it does is it creates and manages a multi-regional Google Cloud Storage bucket. And when you interact with Container Registry, it actually just translates those calls into Google Cloud Storage calls. This means you can probably already guess at how the pricing works, huh? In any case, because Container Registry integrates with the Identity and Access Management service, this can really simplify your builds and deployments within the GCP ecosystem. If you're using external tools, then you have a lot more hassle with auth. Another benefit of staying within the GCP ecosystem is that all the network connections are super fast. And this is especially important when you're dealing with the large amounts of data that might get transferred between the Container Registry and your actual deployment. That said, you can connect with this externally using the standard Docker command line interface. It has native Docker login support. Now, another theme, of course, is that the user experience is quite integrated across many of the GCP services. And here we'll note that the Container Registry is integrated with the Container Builder and Stackdriver logs. It's also not just command line only interactions. There's a console that you can use to manage tags and search for images. Now, since this is a pretty lightweight overlay on top of Google Cloud Storage, you just pay those charges directly. There's no extra cost for GCR itself. Now, once your source code makes its way into a deployment, you may wind up exposing what's running as an API. One of the services that can help with that is Cloud Endpoints. Cloud Endpoints handles authorization, monitoring, logging, and API keys for APIs that are backed by Google Cloud Platform. Now, you might compare this to Amazon's API Gateway service, but it is a bit different, as we'll see in a minute. In any case, this is based on Nginx, and so you might use that if you were doing this on your own. Now, one of the interesting things to note about this is that it is a distributed system and hooks into the cloud load balancer directly. So instead of having a centralized service where all of the requests go to that and then get dispatched, the dispatching happens first and then it comes to one of the proxy instances, which is then responsible for doing the work. This means that it can be super fast and it generally takes less than a millisecond per call, which is much better than a lot of other API gateways. Now, this uses JSON Web Tokens for claims and integrates with Firebase, Auth0, and Google Auth. Cloud Endpoints also integrates with Stackdriver Logging and Stackdriver Trace. Now let's take a quick look at how this works. The client that's making a connection will go through the load balancer and then get sent straight to one of the extensible service proxy containers that are registered for your API. That ESP container gets its configuration information from Google, and it'll check auth and send logs to Google, but it's actually running on your instance, and that's what makes it so fast. You can read more about this at this link here. Another interesting thing about Cloud Endpoints is that it can handle gRPC and even transcode RESTful calls into it. This means if you want to use protocol buffers to get faster performance, you can, and not have to have so much overhead still maintaining your RESTful interface. But do note that the API itself needs to be resource-oriented for this to work. Now, even though the proxy containers are running on your instances, you still pay per call to your API because Google winds up doing the auth and logging. Whereas Cloud Endpoints are at the super fast end of the spectrum, Apigee API Platform is at the super featureful end of the spectrum. Apigee is a full-featured and enterprise-scale API management platform for the whole API lifecycle. You might compare this to Amazon's API Gateway combined with AWS Shield for things like DDoS protection, but on the whole, this is probably closer to the API Gateway that CA Technologies acquired with Layer 7. Apigee can transform calls between different protocols, including SOAP, REST, XML, binary, and custom ones, and it can authenticate through a number of open protocols and authorize via role-based access control. Now, Apigee has a whole laundry list of features, like throttling traffic with quotas or managing API versions. The list is long, and you can check it out in the documentation. Their Apigee Sense feature can notice suspicious behavior, and the API monetization feature can support a number of different revenue models and rate plans. Now, in terms of pricing, the Apigee API platform is not really like most GCP services. While they have team and business tiers that are flat monthly rate with API call quotas and feature sets, but they also have an enterprise tier and special feature pricing that all says contact sales. You may have heard the phrase, if you have to ask how much it costs, then you probably can't afford it. Now let's say that your API is live and running solidly. You're probably going to hook it up eventually to a mobile app. One of the things that can help you with this endeavor is the Test Lab for Android. This is cloud infrastructure for running test matrices across a variety of real Android devices. Now, these are honest-to-goodness real devices in a data center. You might compare this to AWS's Device Farm, or Xamarin's Test Cloud, or Sauce Labs' Mobile Testing. These are production-grade devices that are flashed with an Android version that you want and the locale that you specify too, and then you have it run tests for you. The RoboTest will capture log files and save screenshots and video to show you the steps that it did. And by default, this is completely automatic, but still deterministic so that you can compare one run to the next. But you can also record a custom script if you want. You can also run Espresso and UI Automator tests. Now, Firebase's Spark and Flame plans let you run a certain number of physical and virtual tests each day, and the Blaze plan, which is pay-as-you-go, charges per device hour. Now, I showed you the picture of the physical devices, but there are also virtual devices that you can use, and those are a lot less expensive. Well, all right, we've reached the end of this lecture. If you have any questions, please let me know. If not, please feel free to move on to the next one. Thank you.